Good morning, everybody. Thanks for joining this morning session. I'm going to talk about the new CO2 scrolls that Emerson is releasing. So why are we doing this? So what we want to achieve with this new cool initiative? In fact, we want to be able to offer a new technical solution to the market to really, in fact, help the customers and the market to increase the CO2 participation, let's say, especially for the small and medium store sizes. So how do we do this? In fact, the solution that we are delivering is a simpler solution with compact compressors, which allows to optimize the system and to do some savings on the installation. The way we do this, and I will explain after, is we use the vapor injection. So this is a new way to handle the flash gas. It's much simpler and it provides good efficiency in any climate, any region. The other way to provide the efficiency is with the motor. If you have for the variable speed, if you have brushless permanent magnet, then you have high efficiency everywhere. So this is the way we do this. And we know nowadays with the high temperature that we are facing everywhere during the summer now, it's very important to have a reliable solution that you can be sure that it can operate even under high ambient temperature. So we do that with the pressure rating that we have on the compressors, of course, the operating map, but also the control logic that we have in the solution. So let me explain a little bit about what is the vapor injection, what is it doing in terms of the system. So you see, in fact, you have two main, let's say, design streams today. You have either a standard design. What you do, you take the flash gas coming from the tank and then you re-inject in the suction of the compressor. This is a very simple way to do, but it's not the most efficient because you have to recompress everything through the compressor. Another way to do it is you take the flash gas and then you add a specific compressor, and that compressor is a smaller one and takes the gas at a different pressure and put it at the high pressure. So this is more efficient, of course, because you only compress what is needed, let's say. But the downside is that you need an additional compressor, you need an additional drive, you need an additional heat exchanger. So it adds complexity and cost. So what we do with the new cool compressor, we take the good thing of both sides. So we keep the simplicity of the standard design and we get the efficiency of the parallel compression. And the way we do this is, in fact, we inject the flash gas directly into the scroll. So that's, of course, the benefit of using the scroll technology. It's a continuous compression process. So you can inject the gas wherever you want and at the right pressure to avoid to recompress everything. So that way we have a single design which can operate at a good level in all the climates. So that's really the foundation, let's say, of the technology and the value of it. So it's not only the benefit that you can get by using scroll with CO2. So if you look at the compressor footprint, this is much smaller than an equivalent, let's say, semi-hermetic compressor. It's basically 24 centimeters by 24 centimeters. The reason that it's more compact, it's first, the fixed speed model, they go 2 times faster than the semi-hermetic. And then the other reason is that the variable speed, we can go up to 90 or 100 hertz, depending on the model. So with those two considerations, we can reach a very compact footprint. It's also very much lighter, let's say, than the semi-hermetic. So this is appreciable when you want to use the CO2 system, for example, in spaces where you don't really have a lot of room available, like in the city centers or in some small stores. So that's helping the end user to have more space for the vending area, let's say. So another good feedback that we get with the product that we have provided to different OEM and end users is about the sound. So sound is getting critical again in some application, especially in the city centers where we have more and more. We are getting back to having more and more, let's say, grocery stores in the city, and the sound there is quite important because of the neighborhood and so on. So the advantage of the scroll, as you can see, it tends to be, let's say, quieter than what is available currently on the market. But it's not only a number. It's also the quality of the spectrum of the sound. This is also what is really impacting. And by the way, in one of the field tests that we've been running, the end user, once he came to the machine room and he said, "Hey, the system is not running," and the system was running, but he was used to a given noise level, and that was really a good way to prove that it is definitely much quieter. So if we look at the product range that we have available, so we have the transcritical model, which can be used up to 19 kilowatt in fixed speed, and when you apply the variable speed, then you can go up to 36 kilowatt. For the low temperature, there are two options. Either you can use, in fact, the same shell, and there you can reach 110 bar on the suction. So every model, we have them fixed speed and variable speed. And then the other option for the low temperature, we can go up to 45 bar in terms of the PS. So on the low temp, we can go on the fixed speed 11, 15 kilowatt, and then we can go up to 20, 25 kilowatt when we apply the variable speed. So when you look at that capacity range, that's, as I mentioned before, convenience store is really a very good application. Can be also small supermarket, discounter. So the technology is really well suited for that. Because if you look, you have a simpler system. That's one advantage. And we know today the energy cost, everybody is sensitive to that. So if you have a system which allows in all the climates to run efficiently, that's very much appreciated by the end users. The fact that you have only one design is also easier somewhat, not only for the OEMs, but also for the service people in the field. They don't have to worry, is it what's technology is in the system. They know that it will be always the same. So compactness, as I said, and then you can really pick the pressure level that you want. So at the end, and with those advantages, the people can really minimize the total cost of ownership, starting from the investment to the running cost and to the maintenance cost. So if you look what's inside the compressor, so obviously a scroll, but there are, of course, challenges behind that because the pressure is really high. So not only you have to develop a special shell which is thick enough to withstand the pressure, and by the way, of course, that shell thickness is helping the sound, of course. So the scroll needs to have a special shape because of the pressure. A big topic, and we have a lot of patent in that design because our engineers have been very creative and innovative to find solutions to deal with the high pressure of the transcritical. So the truss plate is definitely a key area that has been developed to be able to go through the high pressure. The BPM motor, as I mentioned before, this is key for the efficiency with the variable speed. and the compactness of the compressor with the small footprint. So we spend a lot of time to develop that technology. We tested many compressors in-house, in performance testing, in reliability testing. We made a lot of sound and vibration. Not only that, we did also a lot of system testing. So we bought some booster in our labs. So what we did, we first tested the, let's say, the competition with the technology to see, you know, where is the technology that is available currently on the market, and then we have put our compressors to see, you know, how it behaves and make sure, especially for all the control development, because this is something that you need to test in the system. We did, you know, the first field test was started 3 years ago. So we did extensive testing, and now we have installation running in different countries and different application. So it's not only a compressor that we have done, as I mentioned, it's a full solution. So where we start first, we generate ideas, and then we go step by step to go to the final release solution. So first, you know, you do a simulation to see, you know, does it make sense to go to the scroll, you know, can we really be there, and so on. Then what we do, we look at the control logic, you know, how do we want to operate, how do we want to inject, where is it safe, not safe. Then, you know, we are also matching the compressor with the drives, you know, making sure that it can start under any condition and so on. And then we start the testing in the booster systems. Then we do, you know, a lot of data analysis to see, you know, how is it running and so on. And then finally, we've moved 3 years ago to the field testing. And now we have this solution package, which is available. So something that I want to mention is about the controller. So we have made a specific controller for this application. So the controller, as everyone knows, it's the brain of the system. And here it takes care and interacts with all the different components of the solution, making sure that it works correctly together in an efficient and reliable way. So it starts with the capacity management, with the fixed and the variable speed, because we can combine fixed and variable speed together. It makes sure that the compressor stays within the safe limit in terms of the speed, the temperature, the pressure. A key thing is about the injection, okay? Because there is a bypass valve, and then you can decide how much flash gas you want to inject into the compressor, depending on the condition you are running and depending on the pressure that you want to maintain. So we have also some interface with the controller where we can, you know, do some monitoring, full detection. We are also, you know, making sure that in terms of vibration, for example, we are skipping some frequencies to avoid any resonance problems. We have the alarm management. We also communicate with the other driver of the system. We have a heat recovery module. I mean, we know energy again is really key. So if we can recover some energy for the heating, that's also beneficial. So about the field test, as I said, we started in 2019. So we've been running different size of stores, some smaller, some bigger. So the good thing, we were able to run the technology during the hot summers, and we had no issue to make it running even during the hot days. So from the customer feedback, I mean, both the end user and the OEMs, I mean, what they really enjoy is the fact that it's really compact. When you see the different system, it's quiet. As I mentioned earlier, we had no major issue, let's say, to report, and it was really easy to implement with the control, with the full solution package. So if I summarize what is the new cool about, so it's about the scroll technology being applied to the transcritical CO2. So this is a significant, let's say, step, and it allows now customers to have different technology to be used in the CO2. The dynamic vapor injection, vapor injection, we've been doing vapor injection in a heat pump, in refrigeration, low temperature. But what is new, of course, here is to apply it to CO2. And we know it's easy to understand, but the fact that you apply vapor injection, it really makes the system much, let's say, simpler. So it's a good fit for the small stores, especially for urban environment. Let's say the value comes not only of the compressor, but also the way everything is managed together. So that's why the solution package is really an important. The good thing also with the variable speed, you have a flexibility, let's say, with only 4 displacements, you can cover a very wide range of application. And then, the technology has been running for more than 3 years now, so we feel really good moving to the next step and implementing more and more application and stores with the technology. So that's about it. Thank you for your attention.